Hey everybody, welcome back. Hope you're all having a great weekend, staying safe and having fun. You are looking at my Geeetech A10m dual color, dual filament mix printer. Before I go any further, let me say that this whole video and this whole project has kind of turned into a soup sandwich, so I hope you'll bear with me because there's probably going to be a bunch of edits in it where I started cussing and things didn't work out right. I know you probably all love it if I just left that in, but yeah, no. So anyway, I reviewed this printer on the channel a while back, and if you saw that, you know that I really like it. And I have used it quite a bit, and I still really like this printer, except for the fact that it quit working right a while ago. And I thought it was the head jamming. So after cleaning the heads multiple times, and even to the point where I tried putting a standard PTFE lined stock Ender 3 head on it and still started having the problems, I started looking elsewhere for the problems, and I found my problem in one of these. This is the Titan Extruder clone, and it is a clone. It is a clone of an E3D Titan extruder, a gear reduction type extruder, and I tracked it down to the one that's on the right. As it's right now, you'll see the two new ones on it, but I tracked it down to the one that was on the right. And I went so far as to replace the cracked tension arms, the pivot arms, with new aluminum ones. I put new gears in it. I tried swapping things around, and no matter what I did, the problem followed this particular extruder. And it was kind of embarrassing because it's not really what you'd call a complex device, but you can't really see what's going on inside of it when it's together and functioning. And it would feed filament through about half the circumference of the feed gear and then not through the other half. I tried putting new gears on it, new bearings, new pivot arm, new spring, everything. Finally it got to the point where I was so annoyed I couldn't go on with it. And a couple of months before all of this started, I had seen these new dual gear Creality style extruders that I think come on one of the new versions of the Ender 3 or one of the others, the Pro maybe. And they were only like $8 on AliExpress, so I had ordered two just for grins and giggles. So just about the time I was ready to carry this whole printer out and drop it in the recycle bin, those two extruders arrived, and I thought, let's try them. So, because my original intro went completely to hell, I'm having to do it now after the whole project is done and working, and you will see them there. And I am going to take you up close and personal to them, explain what they are, show you some of the installation. Hopefully I will filter out all the cussing, and we'll get to the end and we'll see if this was an upgrade or a downgrade, and we'll find out what we think about these new dual gear extruders, or at least what I think about them. And if the 1,000,000 to 1 shot that anybody from E3D is watching this video, I am not dissing your product at all. This was a clone, and obviously not the best clone possible. So with that being said, let's take a closer look at these. Okay, so in typical Creality fashion, they have put the filament support built it directly into the base of the extruder, which is nice. So what you wind up with is you wind up with one of these gears, and these teeth down here, you'll see what they do in a moment, and then this groove here, I don't know how well you can see that, with the teeth in it, that is what actually feeds the filament. So you have one gear coming up through there that's mounted to the motor. Then you have the second gear in the tension arm. And again, it also has teeth down here, and it has a spot here where the filament is driven. So what you wind up with is the stepper motor. Get back on there. The stepper motor, focus camera, come on. I think that did it. The stepper motor is actually driving both gears like that. So both gears are driven, and then the filament is forced through by both gears. So not only do you have both gears being driven, but you have the filament being bitten into on both sides by these gears. So now, with that being said, I have not really had any feed issues after going to an all-metal extruder mechanism. So this could very well be a solution looking for a problem. But nonetheless, they were $8. I bought 2 of them just because I thought it would make a fun video. And then here comes my problem with these things. So I'm going to put one of these on, and I'm going to see what these are all about. And if it works well enough, hell, I might put them both on this printer. We'll see. Let me get one mounted, and I might even show you the video mounting it. Who knows what I might do? Hell, I don't even know what I might do most of the time. Okay, I've got the old Titan Aero extruder on, and the base and the gear for the new one in place. A couple of things to note before I go any further is, one, you need to put the gear on the shaft before you put it together, and I didn't, so I'm paying the price for it. Had to take it back apart. In fact, I've had to take this back apart about 3 or 4 times now, but that's okay, because we learn, right? And we hope we actually remember it till the next time. Leave this corner screw out. This, in my application, this corner screw was too long, the countersunk screw. You're either going to have a shorter one, you're going to have to replace it with something different. There really is no way to properly space a countersunk screw. So in my case, it just made a trip out to the belt sander and became, you know, about maybe 3 millimeters shorter. Because that blind hole only has about 3-4 threads before it hits the bottom. Can't really blame the manufacturer for that. That stepper motor should have been, that hole in that stepper probably could have been deeper. But anyway, that was it. I got it all mounted. Leave this, tighten the set screw on this enough to keep it so that it doesn't turn off the flat, but so that it can still be slid up and down, because it has to. And I'm going to zoom back out a little bit because I don't think I can get the camera to focus or hold my arms that far away. Let's zoom out. Because when you put the pivot arm in, and a couple things about the pivot arm, but first the gear, see if we can get it to focus. This gear won't move up and down, and this whole thing can't be adjusted up and down. So the gear on the stepper motor has to be adjusted so that these teeth here mesh properly, and that this area here that presses on the filament and forces the filament in, it has to match the one on the other gear. That means that gear has to slide up and down. Now, you can do it on the bench with the stepper motor off, which is probably how I'd do it if I had to do it again. I did it on it, and honestly, it wasn't that hard. I slid a piece of filament into it, pressed the two together by hand using the pivot arm, and then just wiggled this up and down until I felt it mesh properly with the filament on both sides. And one other thing is, if I can do this without making a total hash out of it, now this, where the pivot arm actually tightens down, is properly sleeved, so you can tighten the pivot arm down. Just don't go overboard with it, but you can snug it down and it will not bind it up. On the other hand, this here, I'm not going to take it apart because I don't want to drop the parts and have to go hunting for them again. But this gear here has a double needle bearing in it, which is really nice because it makes it run real smoothly. But if you tighten this down, if you tighten this screw down too much, it will squeeze these metal ears together and bind that. So you can snug it slightly and maybe even a little more than slightly, but don't reef on it because you'll bind this up and it won't work. So let's get it the rest of the way together. I think that's all I had to tell you for right now. Yeah, I think that's it. Let's put it together. You want to put the screw in here to keep the screws here and here to keep the spring from popping out. This one is a black one because I thought the one they gave me was too long and was going to make it too hard to get the spring in. And all it's there is to keep the spring from popping out. So, and it's not threaded through from the other side. It's a blind hole. So I shortened it, then I proceeded to set it down and lose it. So that's why that black one is in there. So I can normally get these springs in with my fingers. Ow! Doesn't mean it doesn't hurt, but I can get them in with my fingers. And then all you want to do is tighten this screw down just so it doesn't, the spring doesn't come out. And that's really all that does. You can put a nut and stuff on the other side of it if you want, but that's quite a bit of spring pressure. And since the filament is being gripped on both sides and shoved by a dual gear, I'm going to think that's okay, so and I'm going to go with that.
One thing left to do before we can really test this, and because the Titan extruder and its clones are a gear reduction, and because they use a single gear for reduction, they run the filament in the opposite direction. If they had used and added an idler into it, which of course would have made it more expensive and take up more space, it would have run it back in the correct direction again, or at least correct compared to a direct drive like we're using now. But anyway, there's a couple ways to deal with this. One is to swap some wires around or swap plug around. The correct way to do it is to go into the firmware. Now, if you're like me and you've made any changes to the machine settings from on the machine control panel, you're going to want to note those down before we do this. So what you're going to do is and the Geeetech A10m already has a bootloader on it, so there's none of that stuff that we went through with the early Ender 3s. So all you're going to do is get a USB cable, plug it into your computer. If you're using a Windows computer like me, click the Windows button, or you can right click the Windows button and then click Device Manager, or go and do searching for Device Manager. Excuse me, I've been talking too much this morning. Come down to one of my most common problems. Then come down to Ports Common LPT and find out which port your printer is on. And if it doesn't pop up, restart the computer, try again. If you need the drivers for the CH340, they're over at Geeetech's website. I didn't have to, or if I did, I didn't remember it. So anyway, I'm on COM3 USB serial CH340. That's the Geeetech A10m processor. We can close that. We don't need it anymore. Find your Marlin folder. I'm using the one with the 3D touch, so I'm going to go into that. We're going to go into the Marlin folder inside of there. We are going to find marlin.ino. I'm going to right click on it because I don't know whether it's opening with A10m or Arduino IDE, and right now I want to use the Arduino IDE. So I am going to right click on it and say open with Arduino IDE. When it opens, I don't need this open anymore. We're going to come up to the tabs up above. Well, first thing let's go up to Tools in the menu up above, pull down Tools, make sure board is set to Arduino Genuino Mega or Mega 2560, and processor is set to 2560. Change the port to COM, click on COM3 for the port. Now we're going to come to configuration, I can't say it, configuration H, click on that. And now the easiest way to find this for me is to come up to search. It's about halfway down in this list, I think. Come up to Tools or over to Edit and go to Find, and we're going to click the @ section extruder. I think that'll pop it right up for us. Section extruder, it did not. Is there another one? Section extruder. I thought I found it about halfway down. That is not it. It's down around here someplace. I thought for sure that would pop it up. I guess I'm wrong. I guess we'll have to find it another way. There it is right there. Section extruder. What did I type wrong? Isn't that what I typed? Anyway, there it is. It's under @ section extruder. Apparently there's more than one. But it says for direct drive extruder V9 set to true, for geared extruder set to false. So right now it's set for the geared extruder. We have all falses. We only have an E0 and an E1, so we're just going to change these to true. I'm going to leave the rest of them alone because I don't have an E2, an E3, or an E4. And now we're going to say save it. And now what we want to do is compile it, and the compile button is the check mark, so just click on it. If you get a bunch of error messages about can't do this, can't do that, make sure the COM port is still there and appearing normally, because that seems to be the biggest problem. You've started something else or changed something else, and now the COM port is being locked by Windows. So I go through that a lot with this. It is done. So when it's done, now we want to send it to the printer. And you can do both of these at once. If you click upload, it'll compile it. But we want to send it to the printer. So I'm just going to click on that to send it to the printer. And of course then it compiles again, but it should go stupidly quick because it's already compiled. And then it should send it to the printer. And sending it to the printer is where you'll get a whole bunch of errors about the COM port. This where it says writing at the bottom with the little hashtags going across.
All right,
That
we're
means
back at
it's
the printer.
actually
Our
doing
firmware is flashed. I had taken a wild guess. Well, actually, it wasn't a wild guess. I went over to my Ender 3 and I got the number of steps per inch that it was set at, which is 105, and I tried that, and I was well short of getting 100 millimeters at it. So what I did was, my previous setting was 440, and the Titan extruder is a 3-to-1 gear reduction, so 1/3 of 440 is, well, it's around 150. So I am going to go back into my settings, and I am going to go to control and motion and steps per millimeter, and I'm going to change my steps per millimeter to about 150, or as close as I can get to 150 without it getting too fiddly on me. And what do you know, I hit 150 exactly, and let's store that setting. Store settings. Now I have another, god dang, this filament just wants to go crazy. I have another 100 millimeter mark down there. It's not that one that's really close. I'm trying really hard to get this filament in such a way so that it won't feed well. I'm having to use I had to swap the plugs from this one to this one because this is E0 and the firmware will only let me feed filament through E0. I can't do E1, so I had to swap the wires. At least they're going in the right direction. So let's give it a shot. Everything is still heated. And we're going to come to prepare. And that's not right. Move axis. And move the extruder. And move 10 millimeters. And we're going to dial 100 millimeters into it. 90, 100. So 100 millimeters. Let me zoom you in so you can see the mark coming, and we'll see how close we got this time. This is going to be the charm. This time's going to be the charm. I know it is. Otherwise, I'm going to have to sit down and do real math, and you just don't have any idea how much I hate real math. And my father was a mathematician. So, some of you may think this is ridiculous, replacing a Titan extruder clone with a standard direct drive Creality style extruder. Most people seem to want to go in the other direction. They want to go from the direct drive type to a gear reduction like the Titan. But these are clones and they just have not worked right for me. I don't want to spend, I've already put more money in them than I wish I had of, and still don't have them working right. So I just want to go back to what I'm familiar with. Plus, these are a lot easier to work on and feed than the Titan is. The Titan's just a pain in the tush. And again, the clone. It's a clone. It's not a real Titan. So, if there's 1,000,001 shot and Titan guys are out there listening to this, it's a clone. It's not one you made. All right, there is our mark coming up. Am I zoomed in? Yep, I'm zoomed in. Let's see how close this gets us. That mark should come right up to the body, and it is at the body right now and passing in, and it just stopped. That's perfect. So 150 millimeter steps, or 150 steps per millimeter. Okay, sorry, I accidentally pushed the button went to turn it off instead of the button to zoom out. So we're back in. We have our direct drive dual gear extruder. And we are now in the process of the automatic bed leveling. I'm going to zoom you in. And what am I printing? And you guys know how much I hate printing things that have no use. So I am printing a salt shaker because I just couldn't think of anything else. Because why the hell not, right? Okay, so there is our finished part. Let's take a look at it. And that's pretty decent. I'm not unhappy with that at all. Very nice. This is a pearl white. And you got a little string on the middle in the inside, but who cares? It's like I'm gonna have to do a little bit of working to get those threads to go. There we go. So anyway, not bad. So you guys decide, upgrade or downgrade. For me, it works, so it's an absolute upgrade. Also, I am way more familiar with this style of extruder. I can see what's happening when things don't work right. Seems like a really well built, well thought out unit with the double gears both being driven and the filament being gripped from both sides. And to be quite honest, I don't really see the need for a gear reduction on it. So there you have it. Your or mine anyway, dual gear extruders on the Geeetech A10m. And now this printer is functioning again, which makes me very happy because I have some other projects in mind with it. So, links to everything below. Hope you guys are having a great weekend. Take care, like and subscribe, and I'll catch you the next time. Bye for now.